Okay, so solving exponential equations. Now, you will never get one like this as in part of a problem, but obviously this is what we are going to give you as a challenge to go, can you solve that for x, right? And at the moment, you might look at it and go, ooh, yeah. But in 5 minutes, literally, right, in 5 minutes, you'll go, that's actually not so bad. Now, we're going to start off with the basics. So we're going to start off with a really simple one that you could look and solve just by sussing it, right, by inspection. So if I've got 2 to the x equals 8, I think you can all confidently tell me x has to be 3, right? Unfortunately, the thing on the right, you can't say, oh, x is boom. And I just made it up, so it's probably going to be a fraction, and let's hope it actually has a solution. So what we're going to get into the habit of, as you said, all about the base, We're going to leave our to the x here, and we're going to say, I'm going to rewrite 8 as 2 to the something. So we agree it's 2 to the 3. And this is what I call my ha-ha moment. Ha-ha! Same base on either side. And so therefore, the powers have to equal each other. We agree? All right. So from that, from little things, big things grow, we can make it a little bit harder or more challenging. Let's not say hard, challenging. So what if I went, let's go 1 over 27, oof, let's say x plus 4 equals, what do you think? Come up with a number. It couldn't be 11. I could take a 3.
9.
I could take a 9.
7.
No, couldn't be a 7. We're looking at bases, they're 3 to the something, because this had a base of 2. This is going to have a base of 27, a base of 3, so let's maybe even go 81, right? We can leave it like that. So, gave the game away a little bit where we said it's all about base 3. So choose your base is the first thing. So downstairs, I'm going to, instead of 27, I'm going to write it as 3 to the 3. You are good. And it's to the power of x plus 4. On the right-hand side, 81 is 3 to the 4. All over this. Remember, what we want to do is end up with my ha-ha moment. So we want 3 to the something equals 3 to the something. Now my right-hand side is pretty set. Left-hand side, not too thrilled with. What can I do? Matildes? Okay, excellent. So Matildes is going, let's times, because it's got a power to a power, so that is 1 over 3 to the 3x plus 12. Don't forget to times every one. Yes, Matthew.
You could make it,
Right, I don't want 1 over, I want 3 to the. I want the 3 upstairs. So what do we have to do to the power if we move it from downstairs to upstairs? You make it negative, that's right. And in this case, it'll be minus all of that. So minus 3x minus 12 equals 3 to the 4. Guess what? Ha-ha! It's my ha-ha moment. It cannot be that you can have 3 to the 3 equals 3 to the 4, can you? It's impossible. That would not happen. So if this is 3 to the something equals 3 to the something, it has to be that those somethings equal each other. Would you agree? And now it's a walk in the park to solve linear. So what will I do? Add 12 to the other side, so I get 16, and therefore get rid of a times negative 3, divide by negative 3, so I get negative 16 over 3. Obviously, when you're doing bookwork, you can go to the back of the book, you can check. You can check with your neighbour, did we get the same thing? If it's an assignment, if it's a test, what are we doing? In my day, we would just pop this into the left-hand side, and into the right-hand side and see what happens. So if we've got 1 over 27 to the, what did we say? X plus 4. So minus 16 over 3 plus 4. So minus 16 over 3 plus 4. Drum roll, please. Huzzah! We're correct. For some of the ones that are a little bit harder, especially that one on the right where you go, ugh, there is another tool in our graphics calculator that we can use. Now, my internationals, we did this welcome back. We did this at the start of the year. For the rest of you guys weren't here. So do you remember what we can do to find the solution? Solution. Come on, Gracie, you're good at the calc. Come on.
You don't mean like the solvent?
Yes, I do mean the solve-n. So we would go option, calc, solve n, and you can actually type in that equation. Did you know that? So I could type in 1 over 27 to the, I was doing so well, what was it? X plus 4. Here's my equal sign, 81. Close my bracket, blah, blah, blah. Bang, minus 16 over 3. How clever is that? Did you know that? Right, so just one more time. How do we get that? Option, calc, solve n. And then you type in, that's your x there, and away you go. Your equals is down here. The reason that we want you to be using this is, remember, in this topic, is that essential to be able to do? No. But you are trying to gradually improve your knowledge and the know-how of your calculator, correct? For other aspects coming your way. According to our OneNote, we go to 20D, and there's just a couple of little exercises, or just the one exercise, 2 questions that we do, and you can see they start off so simple that some of you might go, I'm just going to do it in my head and check the answer. So for this one, what would x have to be? 1, because 3 to the 1, x must be 1, right? What would this one have to be? Because 9, we would rewrite, they said 2. We would rewrite this as 3 squared, therefore x is 2. So, obviously, when we get a little bit, show some working. And then, question 2, question 2, yes, please do some working here. I want you to read the questions, so things like this, get rid of the times 6 first, and then divide, okay? This is all setting you up for soon. What happens if you get something like this? What happens if you had 3 to the x equals what's the problem? I can't write 10 as base 3, correct, right? So we know that we could have, oh, didn't want to do that. We know that 3 squared is 9, is on that side. We know that 3 cubed is there. So obviously it's going to be 2 point something, but what exactly is it? So we're going to get to the point where, hey, what happens if we can't put it in the same base? There's another technique that we can use, a better one. Not just the calculator, but yeah, new button on there. All right, so this is what we're aiming towards. So are we good? Can you please make sure that if you have any questions with exercise 1B, please do that, ask me. Then you're going to do 20D. I am leaving it up to you. I mean, my recommendation would probably be start from E. Actually, what's D? Oh, well done. Some people don't get that. They said 0. Good. Anything to the power of 0 is 1. So maybe from E and onwards you go. There's not that many. And then I have an assignment for you. No, you're not allowed to use your calculator for this. So they've got an assignment. Those people are away. When you come back, get an assignment from me. I'll put a copy on OneNote. But anyway. So no calculator allowed. What could we do? Yes? I don't know what you mean by write it out. Yep.
Would you do 8 to the minus 3/5?
You would. So we would. Did everyone hear that? Girls at the back? So to get rid of this, what we want to do is we want to get rid of this. So now normally, let's say if I had, let's do a problem. R cubed equals 17. Now to get rid of the cube, we take the cube root. So that would mean therefore R equals the cube root of 17, or we would say 17 to the 1/3. Yes? So with this, that's right. What we're going to do here is we can go, that means that's x, 8 to the 1/, and now I'm writing this, but you don't have to, 1/3 3/5. Now when we go 1 divided by something, what is it that we're actually doing? David? You flip it. That's right. So we end up with 8 to the 5/3. Now we're not done because remember we're still not allowed to touch our calculator. But hopefully this is one that we can easily do because we're going to separate the 5/3. Hopefully you remember a little bit from last week that 1/3 times 5 gives you the 5/3. Do we agree? Why is that helpful? Because I can now say this is 8 to the 1/3 to the power of 5. What is the cube root of 8? 2. And to the power of 5, so what do we get?
64.
Oh, nice try. 32.